We're looking at exponential functions, and as you go through, there's going to be some vocabulary words, so I'm going to also want you to add those into your vocabulary. So exponential functions would be something like y equals a times b to the power of x. And that's our form here. That a is our y-intercept, and b can be our growth factor or our decay factor. So if b is greater than 1, the function is an exponential growth. And is going up. So it'll look something like this form, and that curve can change a little bit. The where it starts, where it ends, how fast it goes up, that can make a big difference. If it's where b is less than 1, and it's an exponential decay, and I'm going to change this here. We want it still to be within 0. We can't really have negatives is a completely different thing. So we're looking at our decimals like 0.1, 0.2, or any of those in between there, and is going down. And again, how fast it goes down can make a difference, and it just would vary depending on the numbers. When we have these exponential functions, we have what's called an asymptote line. And an asymptote is going to happen in this equation right up here. It's going to happen right down here somewhere. And over here, it's going to happen somewhere in here. And it's the fact, like if you were walking toward a wall and I told you to go halfway there, and you'd go halfway there, and halfway there, and halfway there, and halfway there, if I always told you to go halfway, you should never actually reach the wall. In reality, it's going to look like you're touching the wall, because at some point that distance is so tiny that you would have to do half of. And so it's kind of like you are approaching the wall that it gets to the point where you're almost touching it. This line happens to be where it's a line that a curve is approaching. So it's a line that the curve is approaching. And this is what you should also be writing in your vocabulary section. So the line that the curve is approaching, but never actually touches. So we're going to look at this first one. We're going to have a couple more vocabulary words in here. So 2 to the power of x. Our first thing is that a growth or decay. So 2 is our growth factor. It's bigger than 1, so it's growing. Our domain means which x values would make it true. And without any situation, it's going to be all real numbers. And there's a couple different ways we can say it. We can say it from negative infinity to positive infinity, because all x values would work. That's probably the most common one that we could be using. And then so I'm going to put over here on the side, domain. And these, again, should go into your vocabulary notebooks. So under the letter D, domain is all possible x values. Now, if we put a situation here where we were talking time and money, our domain would most likely start at 0, because that would be our starting point. Negative would mean before I actually decided I was going to double your allowance every week. And there's just no value to that, so that's putting constraints on that situation. And our range would be all possible y values. And we're going to graph this to get that one. So this is where if I put in a 0, so 2 to the 0, I put it in a different color here. 2 to the 0 equals 1. So that means I'm here. 2 to the first would equal 2. So I'm just generating my table. And then if I'm going to double that 2, I'm going to get 4. Double 4, I'm going to get 8. Going the other way, if I did 2 to the negative 1, that's going to be 1/2. And then I'm going to take half of that and take half of that. So I'm going to go right here. I'm never actually touching that line, but I can't draw it quite as nice as that. I thought that would work. That didn't work. I'll just hand draw it in again. It's more accurate for me just to have those pieces in there. So our range, it's going to go from the smallest number to the tallest number. So it's going to go, it doesn't include, so it's going to have our parenthesis 0 to positive infinity. Another way you could write this is y is greater than 0. It's not equal to because it's never supposed to actually equal that piece on the bottom. Our y-intercept, we can see that on the graph. It's where it crosses the y-axis, and it's at the point 0, 1. And our asymptote line, if I was going to draw that in, I would draw it as a dotted line. And it's y equals 0. I'm going to go through another one with you and then have you work on those classwork pieces and just compare your answers. So another way to write this is y equals 0.25 to the power of x. And that would clearly tell us that that b value is between 0 and 1. So that means that we have a decay. And I should know that my y-intercept is 1 because that would be the number that's out front. And then if I multiply that and I multiply it by 0.25, it's going to keep getting smaller and smaller here. Going the other direction, so putting in that negative number, so 1/4 to the negative 1 would actually be like 1 to the negative 1, 4 to the negative 1, or 4. And my other point is going to be way off the graph, so I'm not really going to be able to see it because it's kind of going pretty fast there. And then our domain, if we keep going to the negative x values, we're going to keep going up. It's going to be from negative infinity to positive infinity. When you get into Algebra 2, for sure, you're going to have other graphs that have different domains. A lot of the ones we're looking at still have our domains that all of our x values work, but now our y values aren't always working. With lines, it's a little bit different. So our range, in this case, looking at our y values, is still going to be y greater than 0. If we start changing that y-intercept, that's what's going to make a difference on that. It's not always going to be y is greater than 0. Our y-intercept is at 0, 1. And our asymptote line is y equals 0. It's going to, again, always be that line that this is approaching. You're never actually going to touch that. And so if I raise or lower my graph, that's going to make a difference. You want to work on these next ones and then check your answers on those. And then because we keep coming back to this, I want to just do a couple of them to remind you, this is such important stuff. My daughter was just working in calculus, and some of these things are actually in there in a calculus piece, so it's not like it ever goes away. Slope-intercept form as a reminder, y equals mx plus b. So I'm trying to get y by itself. So I'm going to do minus 3x and minus 3x, and I'm just going to put that underneath because I know those are going to cancel, and I'm moving it just on the other side because they are not like terms. They cannot be combined. And then I divide by 4. I'm going to divide each term by 4 so I get y by itself. 2 minus 3/4 x. I could put that negative 3/4 as a decimal. It is a fraction, but there's no point to actually do that extra work. If you did 2 minus 0.75x, that works. If you wrote it as y equals negative 3/4 x plus 2, that also works. It's just a commutative property. I can switch two things around when I'm adding. Let's look at, I'm trying to think, 5 or 8. Maybe I'll do both of those. So on this one, I have 5/3 y. And I'm going to distribute this. Remember, that's a negative 1. So negative x plus 5. And there's a couple different ways to get rid of that 5/3. One is putting it as a decimal. It is a repeating decimal, so that gets to be a little bit hard. I'm going to do it in 2 steps. So the first thing I'm going to do is multiply everything by 3. So I have 5y equals negative 3x plus 15. And my last step is going to be to divide by 5. There's more than one way to do it. I'm just choosing one. So negative 3/5 x plus 3. And then looking at number 8, I'm going to multiply by 3 first. That's going to cancel this part out of my fraction. So 36y equals 8x minus 48. I could have divided the 8 by 3 and the 48 by 3, but a repeating decimal just makes it a little bit weird at that point. And now here I can divide by 36. Y equals, and then it's nice if we can actually move those or make them a little bit simpler. And so we have 2/9 x minus 4/3. If you are not as comfortable simplifying, it's it's not as big of a deal, but it's more correct. Again, moving to those 7s and 8s, showing that you can do that simplification. So working on that classwork is so important to making sure you're understanding it and that you're checking it. And if you're not getting those answers that I'm getting, that means that you really need to have a Google Meet or check with me.